depicting the situation. Over here on the left, we have the line, horizontal line y equals 10. That's the axis of revolution. Down here, this curve right here is x equals y to the 9th. And the green line is y equals 1. And of course, we also have a boundary x equals 0. So that little red region is what we're going to revolve about the line y equals 10. Since we already have x in terms of y right here, it looks like the shell method is probably the method to use. And I'm coming over here to the bigger picture to talk about that. If we envision a typical shell, the coordinates of this point right here for any y between 0 and 1, that's these y coordinates right here, is the x coordinate is y to the 9th. That's what you do to y to get the x coordinate, which is the length of that black segment right there. So we can say, using the shell method, we're going to take 2 pi times the definite integral from 0 to 1 of the height of the shell is the x coordinate at the right minus the x coordinate at the left. That's y to the 9th. If you want to emphasize it, you could say y to the 9th minus 0. But we're going to multiply that by the average radius, which is the distance from the axis of revolution to the center of the shell. And since that's a vertical distance, it's the y coordinate at the top minus the y coordinate at the bottom. Of course, the y coordinate at the bottom is just this distance right here, which is y. So 10 minus 9. I'm sorry, 10 minus y dy. There's the setup of the definite integral. Now to actually evaluate this, you distribute the y to the 9th, find the antiderivative, evaluate from 0 to 1, and multiply by 2 pi. If I go to board 2, there's the setup of that integral using the shell method. Here's the setup if you wanted to use the washer method. If you're going to use the washer method, you'd have to get y in terms of x, which gives you the same graph, but that would allow you to find the distance from the axis of revolution to the outer radius squared minus the inner radius squared. And that's what this is right here. This is the outer radius squared minus the inner radius squared. Gives us the same answer. Of course, we multiply by pi. And there's the exact answer, 20 pi over 11. That's what you get if you do what I suggested on the first board to evaluate that definite integral. Okay, there you go. Hope that helped. If you have any questions, post a comment.